It's all yours.
Hello, we are the team number 2, and we use vision system to get the feedback in a car. So we will see different objects and determine where they are, and then the robot will move to that object. We applied car vision system with this camera, and we will move this robot. We are Victor, Jonathan, y José Juan Esparza. Bueno, the main idea is the object, the car, is the state, will go to the goal that is a blue object, and then it will reach the object. The materials, we applied DC motors, 2 DC motors to move the car. An Arduino is the microcontroller to control the motors, yeah. 1 H bridge to control go forward or backward the direction of the car, and also when they turn, the car can turn left and right. A webcam. A webcam to know where is the position with the vision system. Water, battery, and the software processing. Processing is like a platform. It looks like Arduino, but it's kind of different. We can read from a text file, so we use it to know where is the position, and also the software OpenCV deliveries. OpenCV we programming in C++. Well, using the libraries of OpenCV, we programming in C++. In C++, the colors, we analyze where are the colors in a screen, so we can find the position of every color that we want to obtain in the field. Here are pictures of the camera. There's the red object. Dale tres. No, para adelante. There is a red object and the blue object. So the red object is reflecting in this screen, and the blue object is reflecting in this screen. So this is without blue, and this is without green. There is some other objects because there are some other blue in the screen. In the
other picture, it looks better. In that picture,
there is a picture. There is a blue car. This is, and the car is holding a blue chip. And there is a blue chip, really tiny, but it can. The program can tell where is the center of that piece, and this is where we can program to obtain the color. We use HSV, hue, value, and I don't remember the last one. It's like a RGB, but it's different to obtain the color, the contrast, yeah.
Perfect.
And we use processing to read the files, because the Arduino platform cannot read files from our desktop, for example. So our program in C++ write in a text file every time that the program says define a position, it will write in the file, and then the file will be reading by the processing, and then the processing will tell the Arduino where is the program. It will be really difficult because we were never working with OpenCV, and neither the processing. So we know programming in C++, so we apply that knowledge to apply in this OpenCV, and then we cannot send the values directly to Arduino, so we have to use different platforms to communicate Arduino, the OpenCV, and also the camera. So we have a mix of every programs. And also the system that we are using is like also like a controller system, a closed loop, because we are using the position. We are comparing the actual position with the desired position. So the car will go forward if the position is the desired position is in front, and backward if the desired position is in back. So it's kind of closed loop because we are also comparing the position, so the car can go forward, backward, left, and right. Okay. Then we will show the the program. We can see here what the camera is watching. Oh, sorry. We can see here what the camera is watching. Here is the car, here is the object, but the camera is watching all of it. But in the red screen, we are only watching the car. And in the blue screen, we are only watching the desired object, the goal. So we will run it to see.
The program calculates the center.
This is the program processing. It looks like Arduino, but it's different. It has different libraries, and as I told you, we can read from files. So we will read a file that C++ is writing. So C++ writing, and then we read it. The processing read it and repeat it again, until the object reach the goal.
Ya está cargado.
We will run in the car. ¿Ya está cargado?
Ya está cargado.
No. ¿Quieres hablar tú ahora?
Ya.
Our goal first was seeing the objects and analyze where the objects are. So we analyzed the red object and also the blue object. It was really difficult because we don't know how to program with these kind of libraries. But at the end, we can obtain the position of the objects and write in a file, and then the processing read the file and go for the objects. We will see how is. Ya está claro.
Yes, please do if you want to watch the rest of the videos. If you've already seen them,
Es que
very good. You want to watch them or? Yes, I'll watch them. Sure. Yeah, feel free.
Lo tienes que volar, ¿verdad?
Yeah, put it a little bit higher, closer to you. A little bit higher. Up.
Okay, thank you.
Estoy corriendo.
Yep. No. Yeah, we had a lot of trouble with that because the wheels are damaged. We think the wheels are damaged because we check the logic and the logic with print screens and with debugging, and the logic it seems be fine, but the mechanical part is a little bit deficient. Yeah, it's running now. Okay, let's go. Go.
How's the battery?
The car is already moving. It's not. The wheel is moving, but the car is not moving.
The right wheel is.
Does it need a little bit more weight?
Yeah.
Will it help if you put something on it?
Okay, we'll try.
Yeah.
You want to put a battery on it, maybe? You want to put that battery on it just for weight?
Yeah.
Just to see if it helps?
The logic is that first goes and try to reach the y-axis, and then go to the other loop and tries to reach the x-axis until reach the object. So first goes to this position, then it's equal in this part, and and tries to turn and reach the
I have a question for you. Where's your X and your Y on the floor? Which is your X and which is your Y?
This is 0 point.
Okay.
And goes over here is the y axis.
Okay, the X is going that way.
Is the x,
Image, which is your X and which is your Y?
y and x.
On the image too?
Yes. Yeah.
Okay, so it is working on your image. Okay. Did it ever work right or only on software?
No, it worked right.
So you have the
video recording with
Okay. Yeah, I was just trying to help you debug it. See what the problem is.
Yeah. Okay. ¿Quieres hablar, Vic?
We think the problem is because the battery sends different current, so the car is moving at different velocities, and also because of the weight, the wheels doesn't touch the floor, so it will not turn for right, for example, if the wheels is not touching the floor. So I think our problem is because of friction more than the software, and also because of the current, not because of the software.
Do you have any PID type?
No.
Or is it you only calculating until it goes straight?
No, we only calculated that go straight. We doesn't use
Okay, so you don't.
not kind of.
So between this point and that point, you don't sample the advanced. You don't correct the.
Yeah, we do it. We are using like a control, but we are comparing the position, the actual position, with the desired position. If it's less than we desire, so it will go forward, and then comparing again, and then if the position is less, is continue less, then we'll continue right, continue forward, forward, and then we are comparing every loop. If the car is in the position desired, if it's not, it will.
What about sleep time? Did you put any sleep time, or did you just run the processor at the fastest speed?
At the beginning, it's like take a picture. We see everything, and then we put a sleep, and then if the position is less than the desired position, it will start the programming. So the first thing that the car will do is goes for the XY. He will.
Yeah, but my question is, when it's going for the XY,
Yeah.
are you sampling and recalculating or not?
Yeah, we are sampling and recalculating. Yeah.
So if I go in a straight line, I take a picture here, I take a picture here, I take a picture here, and then
Yeah.
I always okay. And what is the frequency? What is the time between one picture and the other picture?
We didn't know because it's because of the processing. It's as
You didn't give it a sleep time.
no, we didn't put a delay or something like that.
Just, for example, sample right now.
Okay.
Give it, I don't know, 200 nanoseconds or 300 nanoseconds or whatever, and then resample and give it 300 nanoseconds. Because it takes, how many seconds would it take to go from here to here? About how many seconds? 2 seconds, 3 seconds maybe? 5? 5 seconds? Okay, so if you divide that 5 seconds by 10, you can have every 500 nanoseconds, maybe every half second, you could try to see it. And what that'll do is it won't saturate your computing. I mean, that could be a way of doing it.
Yeah, we are making the sample because for this reason the car.
Okay. See, because there's something right now, it didn't take the picture. If you would have taken the picture, it would know that. Yes, huh? Or else, if it would have sampled when you were over there, your computer would have known that we're already past. So it would have stopped the robot.
Yeah, but we're not doing like sample because we're doing the sample really fast. So it's there.
Sí, ahorita tenía los dos cargados. Cuando tiene los dos cargados se lo pasa por los
Yeah, but what I'm saying is, okay, but right now it passed. So either it didn't sample correctly or it didn't calculate correctly. What are the other half? I don't get it. Okay, so here's the deal. You're progressing 1, 2, 3, 4, 5. Let's take it in slow motion. It's going through here, and you're taking picture and calculating, picture, calculating, picture, calculating, picture, calculating. Well, if it's over here and it takes a picture, it should know that it has to stop.
Yeah.
Okay, but it didn't.
It will go back.
Try to go back. Yeah. Okay. So if you sample this, if you lower the speed of the motor, you should be able to try it out and see if it's the software or the motor. So if you go slower with if you drive your robot slower, you can test it and see if it's the algorithm or if it's the.
Yeah, we do it with PWM, but if the motors doesn't move, I don't know why, because because of the current. So the motors will not move if we make this low.
Lower to
Que no era tanto PWM. Mira.
200.
35. No, sí, muy
Tampoco
bajo.
tan leve.
Do you have the virtual where you actually compute the trajectories? So on your software, you said that you did it with virtual, with the software, and you also did it with the hardware.
Yeah, we didn't make a plot, but we see the numbers of what is the number of the YX and what is the number of the YX from the car, and we can see how it goes, the gap will go less and less and less, and then it will be the same gap, and then it will turn.
And then you'll turn.
Yeah, but we can see with numbers, but not with. We can see it with numbers, but not with.
Ahora está grabando.
Yeah,
That's cool. Okay, and you have the video of it running and everything.
yeah, we have it. Do you want to send this?
Right? Yeah, let's see it. We have it. Let's see it. And then check it.
Es que,
Yeah, you might also want to check if it's the weight of the cable. Like sometimes what you can do is walk with the computer just to make sure it's not the cable that's dragging it.
I think that correctly because the speed is
Slower. Yeah, I think so, because you're going slower here than you are here. You're going a little bit faster here. So, let's see, let's get you guys in front, let's interview you, unless you have anything else you want to say. Anything else, or is that?
No, it's that.
Okay. So how about I interview you all, and just pass the mic to whoever's going to speak. But what were the biggest challenges?
Well, the biggest challenge at this.
Yeah, all three of you can talk if you want.
Well, I think the biggest challenge was that no one has a computer, so we have to do everything in a Mac. So we were never working in that kind of operating system, iOS system. That's the question. That's the problem, because we have to download all the libraries. We have to run OpenCV in Macintosh. We also have to run the processing in Macintosh. We see that we cannot use the same libraries, the same code, and that's what's a big problem. And also working with all the systems all the programs that we doesn't know, like processing, OpenCV. We are working with all the libraries. We are working with text files. We have to learn to read from text files that we don't know how to read. Sometimes we lost the files and we don't know where they are. So it was a problem. And also as you can see, the mechanical system of the car also was a problem, because we cannot analyze when we'll go in line and where we'll go in curve. So we have to. It was a problem for all.
Okay. Anybody else? Anything else that was a challenge for you?
yeah, so another
Just a little bit higher.
as my brother, as my friend says, the programming in Mac is a lot of difficult, because ¿cómo se dice acostumbrado? We are customized to program in a Windows environment, so work with Mac is a kind of different.
Okay, so that was a challenge.
Yeah.
I think the big challenge was was to find the way to communicate the OpenCV language with processing, because we was search a way to make the coordinates of the objects to make be translate to the Arduino, but Arduino by itself can do that. So we lost a lot of time searching how we can communicate the coordinate of the object with the microprocessing.
Okay, so those are the challenges. Okay. Question for you: did you calibrate the space of the camera and the scale of the world?
Yeah, the size of the window.
Yeah, you calibrated that.
Yeah, we did a lot of time because we are doing in some different areas, so we have to calibrate also the velocity of the transmission between the camera and the controller. So we have to changing the size of the camera, the size of the window, it will change the velocity of transmission. We didn't
Okay,
know
no,
that.
what I'm asking specifically is, you have the camera gives you a picture in camera world. And you have X, Y, Z, and you have the world. So you
Yeah.
have an image that is this wide on the camera.
Yeah.
But that is equivalent to 1 or 2 meters going this way and 1 meter going that way, or 1.5 meters. So there's a scale.
Yeah.
Now also, the camera has a distortion, the lens has a distortion. So if you're actually in the center of the camera, the distance between pixels, for 1 pixel or 2 pixels, you're going to have a physical outer world dimension that is much shorter than on the outside of the camera, because you have something called the barreling effect. So one of the things you can do is take a picture with a grid, with just a grid here, reticula, and then you map that onto your camera, and you can get the exact scale at different positions of the camera. If you don't do that, then when you think that you're at 5 millimeters,
We are programming with
with
close eyes.
10.
Yeah.
So that's going to throw you very big errors, very big mistakes, which could also account for some of the difficulties you're having.
Okay.
Because you estimate 10 centimeters and it's really 15 centimeters. It's really 9 centimeters. And the worst part is that here it might be 10 centimeters, but over here it's really the same distance on the camera. It could be 15 centimeters. So I don't know if you calibrated that, or if that's something that you could do in the future.
We didn't.
That you might want to do.
We want to do in the future, but we calibrating for a moment. If we saw that the program is not working like we wanted, we calibrating by
Trial and error?
yeah, try and error. Where is why is not reach the area that we wanted, and then we are changing that, but we are not calibrating that.
A suggestion for the future: you might want to build a map of the physical world with the camera world.
Okay.
And that will increase your accuracy. So that's a good learning experience. And if you ever try it with this same scenario, you might say, oh, that was it. Or maybe you figure out that was not it. And what to do. Okay, so it's a good learning experience.
Another thing that I want to read is that we learned a lot of things doing this project. In the last month, we learned everything about working with vision system. We learned about working with processing. We returned with the knowledge about the motors, how it works, how to control forward and backward. We also we know how to control Arduino with processing. We learn about everything, and that thing that I appreciate is that we learn by our us. We have to search it. I mean, if we go to for a job, our boss will not say, learn this manual and you will know how to do the job. You have to learn in forums, you have to learn with friends, with professors to learn how to program something that you doesn't know how to work it. So that's a thing that I appreciate in this last month that I learned for this project.
Yeah. Anybody else want to? Because I was going to ask you what you learned.
That's
so
what.
you got that. And so if anybody else wants to say what you learned, or if you want to keep on saying what you learned with this project. Anybody else? What did you learn with this project?
Well, this is the first time that I make a project about vision. So all the things that we saw in this project was new for me. Were new for me. So I learned how to program in processing, how to use OpenCV, how to use an iOS system, how to use a camera to any camera that to make vision projects. So all the things in here was new for me. So I learned a lot of things.
Yeah, the same. I didn't have any idea of how to use OpenCV, and by now to the future, I have a lot of projects in my mind that involves the vision system. So this experience opened my mind to think in more possibilities to my projects and make them more interest. And so it's a great
Well, that's very good.
idea.
Okay, so I'll give you my feedback. I think you guys did a wonderful job. Wonderful job. One of the goals that I wanted is for you to learn, because you want to be prepared, like you say, to go out in the real world. Or if you want to go study a master's program or a PhD program, what it's about is for you to be able to identify a problem, find solutions, and put it together. And sometimes it's going to be painful. I'm sure this was a little bit painful. Yeah. Sometimes it's going to be challenging, but I think that by now you discovered you have everything you need to be able to succeed with it. Okay, you tried new things, you went through new things, etc. Now, question for you: do you think you'll continue with this test bed? This is called a test bed. It's a model that you can use. Do you think you'll continue to work with it or not? Following semesters?
Yeah, I think we will continue. Maybe not necessarily this project, but I think we will working with this kind of project like vision system, like controlling motors for a vision system. So I think we will not working in this project necessarily, but we will still working with vision system to recognize the object that you said, recognize an area and know where is exactly there is the position, where is the pixels that is different distance, where is the pixel that is the same distance. So I think we will not working exactly with this project, but we will working with very much with this kind of project. Okay. Well, thank you. We'll send you the video working for your mail.
Okay, so let's include that in the video, okay?
Okay.
So that'll be cool. Excellent. Good
Thank
job.
you.
Anybody want to say anything else? No? Okay, great.